friends, Naji here. Welcome to my YouTube channel. In this video, we will be discussing on how can we build a chatbot, and we will be starting with a simple chatbot. Then we will be discussing about how can we create a context or history based chatbot. Then we will discuss about the creating a chatbot using LangGraph and the memory. Okay. So first we will see how can we create a simple invoke method. This may we already have discussed this, but again we will be discussing how can we create a simple invoke. Here we will have a user. The user will be sending a prompt to the LLM model, then LLM will respond to the user. Okay, so we'll see how this works and its drawbacks also. For that, I have my Visual Studio Code is open here. You can see my Visual Studio Code is open here. Okay, then I have some prerequisites already done, loading the environment file, all those things are done. Okay, so now let me add few more cells. Okay, now we from the LangChain OpenAI, so we will be using the OpenAI for this video. Here I can import ChatOpenAI. Now I can create a model using ChatOpenAI, and I'll be using GPT-4o mini. Let me execute this, then execute this. Okay, so we will have our model ready. Now what we are going to do, we are going to ask few questions to our model. For that, let me create a LangChain core.messages. I can import a human message and I can create a AI message. Okay. So here my query will be, so let me execute this. I can invoke the model. Okay, here I'll be passing a human message. I'm saying that human message. I can say content. I can say I am Naji Abu. I am Naji. I can say this. Okay. So what model says, we can see model says, hello Naji, how can I assist you today? Okay. Now I'm going to ask, so I already told them my name is Naji or I am Naji. Okay. Now I'm going to ask what is my name. I'm going to ask what is my name. Okay. So LLM says I don't have access to your personal data and the users unless it is shared with me, because it does not have any memory. Okay, here I have clearly said, okay, I am Naji Abu. Then the next line I am saying that I am asking that, okay, what is my name? But LLM does not able to figure out my name because there is no memory, or we are not providing any context between these chat or these questions. Okay, so that is a problem with our simple LLM model. It does not have any context, or so that it will not able to give any, it will not able to answer based on any context. So our second approach will be, so let me go to the next slide. Here we can see our next approach will be, we will be sending with some kind of, we are actually, the user will be sending the prompt with history of data. Okay, and what LLM does is LLM will analyze the prompt plus history, and based on that it will send the response back to the user. So we'll see how this can be implemented. Okay, so again I'm in my Visual Studio Code and I'm just doing some copy and paste. Okay, so here I'm saying that, okay, I'm saying human message, I am Naji. Okay, now we have our AI message. So this is the response from the LLM model. So let me copy this. And now I can ask the same question. Okay, so let me ask this, we'll see what it says. Okay, Now it says your name is Naji. How can I help you today? Okay. So what is the difference between the first statement and the first example and the second example? In the first example, we are not providing any context. Okay. So in the second example, we are actually providing some context. We are actually keeping the history of the conversation, and this history we are giving to the model. Okay, so model will able to understand that, okay, his name is Naji, and based on that it will able to understand the or it will able to answer the question. Okay, so that is the second method. Okay, but it is not easy to maintain the history, and it is little difficult, right? So actually LangChain is providing another method with LangGraph. It is actually keeping a checkpoint, internal checkpoint, and it will help us to keep the history very easily in a persistence memory. Okay, so this is the high level workflow of the LangGraph implementation. What user does is, user will be asking the prompt plus a thread ID. Okay, and our LLM model or our LangGraph will save all the conversation between the user and the AI using this thread ID. Okay, and it will save all the conversation based on this thread ID into memory. Okay, so whenever a question is coming from a user with the same thread ID, the LLM model will check, okay, any conversation with this thread ID is exist in the memory. Then if it exists, it will use that as a context or history. Then based on that, it will respond to the user. Okay, and here we are using actually a checkpoint, and we are using a LangGraph also. We'll discuss more about that, and we can do a practical also with respect to this. And consider a user, another user 2 with a separate thread ID. Okay, consider this thread ID is thread ID 1, and another user is coming with a thread ID 2. Then the all the conversation between the second user and the LLM agent will be saved into memory on the basis of thread ID, that is thread ID 2. Okay, so that is how it keeps the memory, and that is how it's actually create the context of each user. Okay. So this is the LangGraph memory. So it's a persistent memory. We can use, like, maybe we can use the SQLite or MySQL in the backend to save all the conversations. Now this is the chatbot that we are going to create with respect to LangGraph. We will have a start point will be here, we will have a model, and we will have a end. We will have a end state will be here. Okay. So one more term that we need to understand before we go into the discussions. Okay, we need to think about, or we need to understand about a state management in LangGraph. Consider we have a different node. Okay, so we have a start node, and we have a node 1, and we have a node 2, and we have the end node. Consider if we need to know, if node 2 want to know state of the node 1. Okay, then we need to internally we need to keep this state. Okay, and for that the LangGraph is actually providing a state management system, and here we, in this example, we will be using a message state. Okay, so node 1 will able to set a particular state. Okay, then when it come to the node 2 will able to access those states. So it's kind of a centralized state which can be shared among the nodes. Okay, so we'll see all those things in our example. We will be seeing how can we create a LangGraph, or we will be seeing how can we keep a state management, and how can we save using the checkpoint. Okay, so let me go to my notebook. Okay, so let me add few more cells. Okay, now we can import LangGraph from LangChain. From LangGraph we can import state graph. We can import state graph, we can import start, we can import end. Okay, and we can import the message state also. Now from the LangGraph, from checkpoint memory, we can import the, now we are going to import memory saver. Okay, so this is our checkpoint. Now we can build our node. So for that, first let me create a workflow. So state graph, here I can pass the state schema. State schema will be message state. Okay, so if you go to this message state, okay, so this is actually maintained by the LangGraph. We can see that message state is a type dict. It is actually keeping a variable that is called the message. So we will able to add the message to this particular state. Okay, now we can build our node. So our first node will be, there will be only one node called model. Here we are actually passing a state of message state. Okay, then here we have a response. We'll explain that. This we will have a model dot invoke. Okay, and here we are going to invoke. For that we need some something in the query, right? For that we will be using the state. From the state we have a messages. Okay, so in the model dot invoke we will be passing the state and the state message, I mean the value within this state. Now I can return, here I can return messages, I can return the response. Okay, so whenever, so just understand this method. Okay, so this is a Python function, and here we are actually sending a message state, and consider this as a dictionary. Okay, and model dot invoke will actually getting the prompt from state dot message. Okay, and we based on this we will be getting the response. The response will be returning as message, as a message. Okay, so whenever we return this will automatically update the message state. Okay, so now let me execute this. Okay, now we can build out graph. For that, first I can add a node. We'll be adding a node first, a normal node, that will be my model, and this will be my call model. Now I can set my edges, add edge. Here it will be, first edge will be start, and from the starting to we will be going to model. Then I can add a edge. From the model to we will go into the end. Okay, now the workflow is ready. Now we can implement the memory saver. So memory, let me initialize a memory saver. Here we have our memory saver. Now we can have our, we can compile our workflow. Okay, with this checkpoint. Here I will be saying the checkpoint, and checkpoint will be memory. Okay, once this is set, all the conversation will be saved into the memory. Currently we are using the in-memory saver. Okay, so let me quickly go back to our slide. Okay, so in the slide we have mentioned that the user will be sending a prompt with the thread ID, right? So we need to set the thread ID. For that, what we can do, I can create a configuration. Let me set a config. Okay, here I can create a configurable. Here I will be setting my thread underscore ID and thread underscore ID. Sorry, you can say that ABC123. So this is my thread ID. So whenever I invoke the model, I will be passing this thread ID. Okay, now I can set my query. My query will be I am Naji. Okay, now I can let me write it here itself. My input message will be human message. I am passing this query. Now we will have our output. I can say that invoke. Okay, here I am passing the invoke the message variable, the messages. Here I am passing my input message. Now let me execute this. The check pointer requires one or more. Okay, see the error. So it says that check pointer requires one or more following configurable keys, that is thread ID. Okay, so let me pass the config also here. I am passing the config also here. So let me execute this. Config is not, sorry, should be config. Thread ID. Okay, something is wrong here. Let me check. It is thread thread ID. Seems to be correct. Let me check. Output is truncated view. Key error thread ID. So it should be something issues there. So let me check this. We have a configuration. We have a config here. We have a configurable. Okay. Then we have the bracket is open. We have thread 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 underscore ID. Okay. Here we are saying ABC. I am closing this and I am closing this. Should be working. So let me run it again. Okay, it's again says an issue, so we need to analyze what happened to thread ID. Okay, so let me remove this and run this. You can check this. Checkpoint config by thread ID. Let me copy this. Maybe I will post the video, then I will figure out this. Okay, let me run it last time. Okay, so let me post the video, then let me check. I will correct and we will start again. Okay, I don't want to waste the time. Okay, so I have figured out the problem. Okay, so the problem is actually with respect to a spelling issue. So here we can see that it's not configurable, right? It's actually a extra T is here. So let me remove this. Okay, now we can execute this. Okay, so we will see that we have the execution is done. Now we can try to print this. Okay, I can select maybe the last one. First let me print the output. Okay, so here we can see, maybe let me run it again, everything from the start. Okay, now we can see, so this is my message. Okay, so this is the human message, hi Naji, and this is the AI message, hello Naji, how can I assist you today? Okay, so to see this little bit of neat, I can select the messages. Okay, so let me select the last one, and here I can say that pretty print. Okay, so this is the message from our AI. Now I can just copy this, I can paste it here, and I can say what is my name. Okay, now it says your name is Naji. Okay, now we said that it is actually getting the value based on this config, right? So we can do one more thing. Okay, here I can take a config and let me change this into 1 2 1 4. Okay, I'm changing this. Now I can ask the same questions here. See, so since the thread ID is changed, it is checking the memory based on this thread ID. Okay, since this is a new thread ID, it says, I'm sorry, I don't have any access to your personal information. Okay, that is good. Now we can see how this memory looks like. So we have our memory, right? Let me print the memory. Maybe let me run this config again. Okay, now we can see how the memory data will be. Okay, so the memory is a generator. We can check memory dot, I believe we can check memory dot list. Yeah, we have the list and we can have the config. Now I can print the not from for. I can print the memory. See, we can see all our checkpoints. Okay, it's keeping something like here. We can see the usage tokens. Somewhere here we can see all our details. See, he can see that, okay, a message, your name is Naji. So all those details are saved in our in memory. Okay, based on our thread ID. So that is how this works, and we can print our one more last thing. We can print our LangGraph also. For that, I have my display. I can import image and display. Okay, here we can have our display and image. I can have my app dot get graph. Okay, so this is one graph dot. Okay, we can see our graph here. See, so this is our graph. We have a start and we have a model and we have an end. Okay, so in this way, using LangGraph, we will able to create a very neat and clean chatbot applications. So let me have a quick review of what we have done. We have actually used a LangGraph. So LangGraph is actually providing a message state and a memory. So this message state is used to save the state between the nodes, and the memory saver is using to save the conversation between the user and the LLM model, or user and the agent can be saved using the memory saver. We can have a different savers, memory savers are there. We can have a in-memory saver, we have a Postgres saver is there. All those savers are available. But in this video, we will be discussing about the in-memory saver. And we have created a state graph using the message state, and we have created a model, okay, a node. So the node is actually taking value from the message, value from the state, and it is returning the response. So whenever it is return the response, this will automatically update the message state also. So that is a property of a LangGraph. And we are building our node. So node is built and we are building our edges. Okay, so that is also done. Now we are creating a memory saver, and using this checkpoint we are compiling our LangGraph. Okay, and we have set our configuration, and based on this configuration, or especially with this thread ID, we will be invoking the model. Okay, here we can see, just have a look on this particular 3 lines. This is my query and this is my input message. So whenever I call app.invoke, I am passing this message, okay, this input message to this message here. So this will automatically come to my message state, and from here the model is getting my prompt. Okay, so that is how this works. Okay, so we have discussed about the thread ID. So the next what we have discussed is, whenever we change the thread ID, we will get a different output. Okay, so that is about in this video. I believe everybody have a clear understanding about the chatbot, and if you have any questions, please put your query into my comment box. I will try to reply that. And one more thing, I have actually created another playlist for LangGraph, and which contain only the basic details. So if you want to know more about this, please refer my that particular playlist. I will add that into my YouTube description. So that's it. So please do like and subscribe. Have a nice day. Bye bye.